Welcome back to Coursera, the story about the anatomy of the upper limb. Let's continue our discussion now about how the innervation of the upper limb is organized, extending our conversation that we began last time about the anatomy of the brachial plexus. As we said then, the brachial plexus contains or consists of 5 roots that are components of the C5 through T1 spinal nerves. What we now want to extend using some animation is how the brachial plexus undergoes what we would call a functional resort as part of the intermingling process. And by queuing up the animation, the point that we want to make is this. At the earliest part of the plexus, after there has been an initial joining or intermingling of the C5 through T1 roots, there is a branching pattern that resorts the plexus into a set of anterior and a set of posterior division fibers. They're still the same motor axons of nerve fibers that are found in the roots, but through a differential intermingling, they have resorted themselves. And what you see shown on this slide is the fact that on the anterior part of the brachial plexus, we see kind of an M-like array of intermingling of the anterior division fibers. And what is the end result of these anterior division fibers is that they give rise to 3 nerves that will contain those anterior division fibers going forward. And they are the musculocutaneous nerve, the median nerve, and the ulnar nerve. What is significant about any nerve that contains anterior division fibers? They will end up coursing on the anterior aspect of the upper limb and mainly innervating skin and muscles on the anterior aspect of the upper limb. And what we've just said in a previous lecture is kind of a major function of muscles on the anterior aspect of the upper limb that are acting to decrease an angle between corresponding body parts is that many of the muscles innervated by these 3 anterior division nerves will act as flexors. Then, in a slightly simpler reorganization pattern, you can see that there are a set of posterior division fibers, illustrated in blue, that again give rise to 2 nerves, the axillary nerve and the radial nerve. And using the same analogy, these 2 nerves are going to spiral around the humerus outside of the axilla and innervate muscles on the posterior aspect of the upper limb that are going to act in a major way as extensors. So this kind of gives us a functional percept of how the branching pattern of the brachial plexus has been following now a functional theme. Then the other interesting point that we want to make, and we'll kind of do it over here on the right side of the figure, is that running down through the brachial plexus is what we would kind of refer to as a proximal to distal gradient of innervation. All right, prox up there and distal down there. This is also valuable to understanding the organization of the brachial plexus. And what this means is nerves that contain the roots of the plexus, including C5 and C6, are likely going to innervate muscles that are acting at a proximal joint in the upper limb, in this case, the shoulder or possibly the elbow joint. Whereas nerves that contain C8 or T1 are likely, based on this gradient, to innervate more distally positioned muscles, probably more likely to be found at the wrist or definitely in the hand. So this gradient of innervation gives us an additional clue about the functional significance, mainly of the big 5 nerves that are arising from the brachial plexus. So using that, what we've also shown in the cross sections down here at the end are the spinal cord segments that are commonly found in these 5 major nerves that arise from the plexus. For example, you can see the musculocutaneous nerve is mainly a C5 and C6 nerve because it's a virtual continuation of the upper part of the brachial plexus. The median nerve in the middle of the M is C6 through T1, meaning that it probably doesn't innervate any shoulder muscles, but because it has T1, it definitely will innervate some intrinsic hand muscles that arise and insert in the hand. Ulnar nerve, pure C8 and T1, definitely going to be an innervator of distal limb muscles, mainly those in the hand. Axillary, on the other hand, being that it is like musculocutaneous in only containing C5 and C6 fibers, it will only innervate muscles that act at the shoulder. And radial nerve, C5 through C8, will innervate a muscle that does cross the shoulder joint, but it will also innervate arm and forearm muscles, but it probably won't innervate any intrinsic hand muscles because it lacks the T1 spinal cord segment. Then our last point about this picture, and this will come up a little later in our conversation about the upper limb. Note that a structure known as the upper trunk and a structure known as the lower trunk are probably the most common sites of an injury inside the brachial plexus, usually caused by stretching, trauma, or some form of compression. But now, based on the gradient, we can almost predict where a patient might have weakness. Because if the upper trunk of the brachial plexus is compressed, certainly based on the gradient, proximal muscles are likely to be affected. Whereas if a patient has a stretching or compression of the lower trunk of the brachial plexus, more likely the effect is going to be on distal muscles, hand muscles, particularly in the upper limb. Now, we've looked at this in our digital atlas, but now again a reminder that we can see again the M of the brachial plexus illustrated there. We saw this in our previous lecture in the cadaver, but now we know something additionally significant about the M. It contains anterior division fibers that end up coursing in three nerves, musculocutaneous, median, and ulnar, that will be in a position now to innervate muscles and skin on the anterior aspect of the upper limb. And again, we're also making the point that the brachial plexus is largely giving rise to its branching pattern, its interweaving pattern, while coursing around the blood supply that is developing in the axilla as part of the upper limb. Now let's get specific about the nerves that arise from the brachial plexus and where and what muscles they're going to act on, again using our clues that we've already elucidated about whether they contain anterior posterior division fibers and the spinal cord segments they contain, which will be a predictor based on the gradient of where we will find the muscles being innervated. First off, musculocutaneous nerve, elegant netter picture shown on the next slide. Again, because the musculocutaneous nerve contains anterior division fibers, and because it contains the spinal cord segments of C5 and C6, it is going to be the exclusive innervator of anterior arm muscles. Anterior arm muscles are biceps brachii, brachialis, and coracobrachialis. We're not going to identify them specifically as yet on this picture, but suffice it to say that collectively, these muscles have the capability of crossing the shoulder joint and acting as flexors there, crossing the elbow joint and acting as a flexor there, or in the case of the biceps brachii, attaching to the radial tuberosity and acting as a supinator. But again, the bottom line is these three musculoskeletal innervated muscles are in the anterior arm and are predictably being innervated by the musculocutaneous nerve based on the gradient of innervation. Then number two, median nerve. Median nerve's got lots of spinal cord segments in it. Typically, it has the C6 through C1 segments in it, and because it doesn't have C5, we can see that the median nerve innervated muscles begin by acting at the elbow joint, but not at the shoulder joint. The median nerve is the major innervator of anterior forearm muscles, and they're going to play a major role in flexing the wrist and flexing the digits, and a minor role because they cross the elbow, they must act at it, playing a minor role in flexing the forearm at the elbow. But then, since the median nerve contains T1 fibers, it is allowed, me giving it permission, to pass into the hand and innervate muscles that we identified earlier in the thenar eminence, basically at the base of the thumb, and acting in different ways to move the thumb. And lastly, you can just see a hint of them here. There are two very important little intrinsic hand muscles that somebody thought looked worm-like, so they named them lumbricals. Those two small but yet important intrinsic hand muscles are also being innervated, largely by the T1 fibers in the median nerve. Then, let's look at the ulnar nerve. The ulnar nerve, as we said, is the last of our three nerves that contains anterior division fibers, but it contains C8 and T1 spinal cord segments, so its major distribution must be distally. It's only going to innervate 1 1/2 forearm muscles, most of them in the anterior compartment of the forearm being innervated by the median nerve, and it's only going to innervate a lot of intrinsic hand muscles, muscles that will form part of the hypothenar eminence at the base of the pinky, and a number of other intrinsic hand muscles, basically all of those collectively that are not being innervated by the median nerve, because the median nerve and the ulnar nerve will be the only two nerves of the brachial plexus that contain T1 fibers and are therefore allowed to innervate a muscle that starts and ends in the hand, an intrinsic hand muscle. Then, let's look at our two posterior division nerves, and in this case we've turned the upper limb onto its posterior side because both of the axillary and radial nerves have spiraled around different parts of the shaft of the humerus as they emerge from the brachial plexus, and they're adopting this posterior course because they contain posterior division fibers. Well, the axillary nerve is first, and it, as we've indicated, only contains C5 and C6, so it can only innervate two muscles, a teres minor and a deltoid, that act at the shoulder joint based on the gradient of innervation. And then lastly, we can look at the radial nerve. The radial nerve has as many spinal cord segments as the median nerve, 4 out of 5 of them, C5 through C8 collectively. And this puts the radial nerve in a position to innervate the sole posterior arm muscle, which will be the triceps brachii, and also gives us the opportunity to innervate all of the posterior forearm muscles that are going to act mainly as extensors of the wrist and contribute to extension of the fingers and fully extend the thumb. But again, we can see that since the radial nerve doesn't contain T1 fibers, it can certainly innervate muscles whose tendons will extend into the hand, but it will not be the innervator of any intrinsic hand muscles based on the gradient of innervation. And then lastly, let's kind of compartmentalize what we've said with a couple of cross sections through the arm and forearm. And this is kind of useful as well in providing a mechanism to identify a fundamental nerve that's innervating major muscles that are found in various compartments. So doing that, if we first make a horizontal section through the arm, we subdivide it into posterior and anterior compartments, and that's easy because all of the muscles in the anterior compartment of the arm that are acting mainly as flexors, as we saw, are innervated by the musculocutaneous nerve, and all of the muscles in the posterior aspect of the arm acting as extensors are innervated by the radial nerve. Then things get a little more complicated down in the forearm because we saw that the major innervator of flexor forearm muscles was the median nerve, with the ulnar nerve playing a relatively minor role. But then all of the muscles in the posterior aspect of the forearm will be dutifully innervated by the radial nerve. And then finally, when we move down to the hand, we know that the intrinsic muscles of the hand have to be innervated by a nerve that contains C8 and the T1 fibers. And that is simply going to be the job of the median nerve and the ulnar nerve, because these are the only two nerves that contain C8 and T1 fibers, and therefore will be the two nerves that we're going to innervate all of our intrinsic hand muscles, regardless of where we find them. Now, having sorted out the functional anatomy of the brachial plexus, we can kind of revisit it again in our 3D view, noting first the significance of the three nerves that contain anterior division fibers. And they again were the musculocutaneous nerve arising off one side of the M, the median nerve arising from the middle of the M, and finally the ulnar nerve arising from the medial side of the M, each of them containing anterior division fibers and finding muscles and/or skin on the anterior aspect of the upper limb. Then if we swing around posteriorly, we can see the two nerves that contain posterior division fibers, and they will be, if I can click on it, there it is, this one and this one. So the longer one that's spiraling around the middle of the humeral shaft is the radial nerve, larger because it's got 5 spinal cord segments that help make it up, compared with the much smaller axillary nerve that you can see curving back upward to innervate just 2 muscles that are acting at the shoulder joint.